So yeah, hi guys, welcome to the fourth sitting, actually third sitting that we are going to be holding today. Before that, we had learned everything that we had to learn about quadrilaters, including some sums from our exercise 8.1. We had learned various theorems related to that. Today, we are going to learn two more theorems that are left for this chapter. They are related to triangles, but we are going to learn them today. Hopefully, we will be able to complete that and along with the sums that we had left. So let's start with that one. I hope you guys understand this. You already recall what we have learned earlier. With that being said, let us start with the video then. So let's see what do we have for now. So before we get to the point, let's recall everything that we have learned up till now. So for a quick revision, see, you guys already understand what quadrilateral was, right? A quadrilateral was what? It was made up of two words, quad and lateral. Quad was four, lateral was sides. So any figure which included four sides, that will be a quadrilateral, right? It had four vertices. I have these four vertices. It had four angles also. Don't worry, this is not 90. They necessarily won't be 90. They can be, but they don't have to be. There will be just four angles because we have four vertices. So let's say I have a quadrilateral ABCD such that we have four sides AB, BC, CD and DA. We have four vertices A, B, C and D, and we have four angles, angle A, angle B, angle C and angle D. So this figure, for general reference, if AB is not equal, none of the sides are equal, none of the angles are equal, then that figure will be just simply called a quadrilateral. But once we get to the point where we understand its properties, like what is the figure will be called, what the figure will be called if its opposite sides are equal and parallel, if its opposite angles are equal, if each angle is 90 degree, if all sides are equal but none of the angle is 90 degree. So each and everything will be discussed. We have already discussed that. So I will be writing this name right here. So before the very first type of quadrilateral, that was your parallelogram. So what was the property of parallelogram? It stated that opposite sides must be parallel and they must be equal. That means they will be of equal length. Opposite angles were equal too. So each and everything here. See, opposite angles will be equal, opposite sides will be parallel and equal, and diagonals just bisect each other. They are not equal, they just bisect each other. While we move to the second type of quadrilateral, it was a rectangle. So you guys remember what a rectangle was? A rectangle was that kind of a parallelogram in which, and one more thing, here none of the angle is equal to 90 degree. That was the main thing here. None of the angle will be 90 degree for the case of your parallelogram. And while we were in rectangle, opposite sides were equal and parallel. Each angle was exactly 90 and diagonals were equal and they bisected each other too. But they were not bisecting at right angles. That means if I join AC and BD, so AC will bisect BD, but AC and BD, they won't be perpendicular bisected to one another. So that means if I joined these two diagonals right here, let's say they intersected at O, then AO will be equal to OC, OB and OD, but they won't be 90 degree. That was the main thing regarding a rectangle. Then we went on and moved towards what? Let's firstly write rhombus, then we'll go towards square. So you guys see what a rhombus was. It was a figure. It was a kind of a parallelogram in which each side was equal. None of the angle was 90. Diagonals were not equal, but they were perpendicular bisector of one another. So that means this half will be equal to that one. This half will be equal to that one. And angle here will be 90. So that was the main thing regarding your rhombus. And majorly each side will be equal. Remember, rhombus and square, they have somewhat properties similar, but none of the rhombus can be called a square because in square each angle is 90 degree, diagonals are equal diagonals, they bisect each other at 90 degree too. That means in square each angle will be 90, each side will be equal, diagonals and their halves will be equal as well, and they will be perpendicular to one another. So that was the case of square. And lastly, we had understood about the kite. Then we went towards the your trapezium and everything, right? So kite was what? Kite was a kind of a figure in which we had adjacent sides equal. That means these two and these two will be equal, and the longer diagonal was bisecting the smaller one. Longer will be bisecting the smaller one, not smaller the longer one. That means this half was equal to that one, and angles were 90 as well. So remember, that will be the case for the kite. Don't get confused with kite and rhombus because they are totally different things. So a kite cannot be a rhombus cannot be a kite. A kite can, see, there can be another thing. See, in rhombus, each and every side can be equal. So you can say rhombus can be a kite, but a kite cannot be a rhombus. That is the main thing. Kite cannot be rhombus, whereas we can go other way around. That can happen. Similarly, I can call a square as a parallelogram. I can say a square is a parallelogram, but I cannot say a parallelogram will be a square, because in parallelogram only opposite sides are equal, while in the case of square, since each and every side is equal, you can easily say that opposite sides are equal as well. So square can be called a parallelogram, but not the other way around. So you have to keep that in mind, because we are going to use these proofs for some sums that we have today. I will be showing some new ways in which you can attempt to prove something that you have been given in the question. See, your congruency is one thing. You can use congruency. You can consider triangles in majority of these questions, but I don't want to get you guys just keep on using congruency. There can be various other ways in which we can solve them, so I will be telling those as well. So let's recall everything, since you guys are able to recall. I hopefully think you are able to recall each and every property of a quadrilateral and every type as well. So you guys see, sum of all four angles of a quadrilateral, it was 360. You guys remember that. Diagonals of parallelogram divided into two equal congruent triangles. That was easy. You guys also remember this. If we had joined a diagonal, these two triangles will be equal, and they will be having same area. That you will be learning in your class, in your chapter 9. Now, a quadrilateral is a parallelogram. See, you will be calling a quadrilateral a parallelogram if opposite sides are equal, opposite angles are equal, diagonals bisect each other. Now, a quadrilateral is a parallelogram if the same thing, opposite angles are equal, opposite sides are equal, and diagonals bisect each other. Pair of opposite sides is equal and parallel. So remember, these are the converse. You can prove, if these conditions are given to you, you can easily prove that that figure is a parallelogram. If you have been mentioned that the figure is parallelogram, so these conditions will be true as well. So diagonals of a rectangle bisect each other. We have discussed everything. Diagonals of a rhombus bisect each other at 90 degree. We have also understood this. Square and everything. We have understood each and everything from this. See, line segment joining. This is the theorem that I'm talking about. This and its converse. See, the theorem is your midpoint theorem, that a line segment joining the midpoints of any two sides of a triangle is parallel to the third and is equal to half of it. This theorem will be discussed today. And the line through midpoint of one side of a triangle parallel to the other, it bisects the third. That is the converse of a midpoint theorem. We will be discussing these two theorems later on in this video. I will be explaining how such thing exists, and then we'll shift towards the remaining portion of this chapter. Then we will be having a revision session as well. So that being said, let's start with the video now and let's get to the sums. So firstly, let's recall everything that we had done in our last session. So we had done 3 sums, right? So this was the easiest sum of all, in which we had what? We had 4 ratios. The angles were in ratio. We had to find out each and every angle of the quadrilateral. I had showed you 2 different methods, in which once you could have taken the ratio to be x, and in other you could have taken the sum of ratios. So in both ways you could have easily solved this one. So if you had taken your ratio x, it would have been like this: 3x plus 5x plus 9x plus 13x equals to 360. Since you guys remember, sum of all 4 angles is 360 in the case of quadrilateral. Now here you could have gotten the value of x, then you would have put it there and you would have got each and every angle. So I hope you guys understand this. Another way was this one, in which you will be using the sum of ratios. You guys already remember this. Firstly, you have to find out all the sum of entire ratios. That was in our case 30. Then we will be putting part by part. So if out of 30 we had 3 part of first angle, so 3 by 30 multiplied the total angle, which was 360. You could have easily got that one as well. So this is how you're going to do if you have been given ratios. So that was the case for your first sum. Now let's move forward and see what we had in the second part. So in second we had what? Diagonals of a parallelogram are equal, and we have to show that it was a rectangle. So we had proved that in a figure in which diagonals are equal, then that will be rectangle. Now you guys already remember, in the case of parallelogram, opposite sides are equal and parallel as well. So we have to just make sure that if the diagonals were equal, then ABCD will be the parallelogram. Now ABCD will be the rectangle. Just one more difference here. Since you have been mentioned diagonals are equal, the one more thing that you can do is, just to make sure the given figure is a rectangle, just prove each and every angle to be 90 degrees. So this was the proof right here. We had taken 2 triangles, then we had assumed the equal sides, and then we had proved them congruent. Then using the congruent part of congruent triangle case, we had proved the base angles to be equal. Similarly, we can easily prove each and everything. So that was the case of a second sum. I hope you guys are able to recall this one. Now let's move forward and see for the third one. So in third we had what? If the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. See, you have been given that the diagonals of a quadrilateral bisected each other at right angles. So you guys see, I had already taken this figure in which each of these angle was 90 and the diagonals are bisecting each other. That means half of this. That means this, if this was O, then OA was equal to OC and OD was equal to OB and this angle was 90. Then you could take firstly these two triangles. OD is equal to OB, OA common, this angle is that one 90, so side triangles are congruent. You could say AD was equal to AB. Then you could take these two triangles, you could say AD was equal to DC. Similarly, you could have proved each and every side to be equal, and ultimately, if all four sides are equal and diagonals are bisecting each other at right angles, that figure has to be a rhombus. Firstly, it will be a rhombus, then you can easily prove later on if you want to that it will be a square or not. But for that, you have to make sure that diagonals are equal to. For the case of square, each angle is 90 and diagonals are equal themselves, while in our case, we have been just given that diagonals are bisecting each other at 90. They are not given equal. So that will be the main difference here. I hope you guys remember this because we have one more sum based on this concept now. So the next sum is, let's start with the exercise today now. Show that the diagonals of a square are equal and bisect each other at 90 degrees. Now we have to do what? We have to show that diagonals of a square are equal and they bisect each other at 90 degrees. So for this, I'm going to do what? I'm going to draw a square. Let's draw a square. So let's say ABCD is a square. And we have the diagonals AC and BD. Now we have to do what? We have to make sure that diagonals are equal and bisect each other at 90 degrees. First of all, we have to show that this will be equal to that one, this will be equal to that one. Ultimately, each and every side must be equal. Then we have to prove that they are bisecting each other at 90 degrees. That will be the main thing. Now for this question, let me just ask you something. Since you guys already know it is a square, then what can you say about if I take these two triangles? If I do what? If I take these two triangles, let's start with this one. Let's say this is the triangle first. And let's say if I take this one, this as well. So guys, see, we have two triangles right here in which I can see AD can be proven equal to BC because that is the simplest case. I can see this side is common. What else can you see here? See, one more thing we can do here is what? See, if you take these two triangles, this side is common and this is equal to that, then you need to have angles. Now you guys know it is a square. Each of the angles will be what? They have to be 90, right? So you can take side, angle, side. You can easily prove that these two triangles are congruent. Okay, you have just proven that the two of the triangles that we have taken, they are congruent. Then I can easily say BD can be equal to CA, right? Diagonals can be proven equal, right? So if the diagonals are equal, they are intersecting at this point O, half of our portion is done. We have to firstly show that the diagonals of a square are equal. We have proven them equal. Then we have to show that they are bisecting each other at 90 degrees. For that, we have to do what? We have to take at least these two angles. We have to take these two triangles. Then we have to prove them that they will be, these two angles will be what? They will be 90. They will be equal. Then we can take linear pair and easily prove that they are equal. And for that, if you are just going for it exactly, remember this, you can easily say these two sides are equal. You can say this is common. But for the next one, you don't have anything. You just know the entire diagonals are equal. Their halves are not equal. For that case, firstly, you have to make sure that they are bisected as well. So for that case, you can do what? You can go for the Euclid axiom as well. You can say if holes are equal, then their parts will be equal as well. That means if AC is equal to BD, then obviously their halves will be equal to each other. But that is not the case since you haven't proven that they are half. They are actually divided. They are not yet divided. We have to prove that they are divided. For that case, we are going to do what? We are going to take these two triangles for now. I'm going to erase this and let me tell you which triangles am I talking about. So for this, for proving that they are bisecting each other, we will be taking these two. Now in this case, the question will be arising in your mind that we only know that these two sides are equal. We don't know anything about this. But for now, you guys remember a square is what? A square is a parallelogram, right? I have told you that we can say a square can be a parallelogram. So if square is a parallelogram, then its opposite sides have to be parallel. So if AD is parallel to BC and AC is the diagonal, so AC is the transversal for now, we can easily say this angle will be equal to that one, alternate interior. Similarly, if AD is parallel to BC and BD is what? BD is your transversal. So you can easily say this angle will be equal to that one. And you guys already know angle, side, angle. Triangles will be congruent, and you can easily say that OA will be equal to OC, OD will be equal to OB. Since you guys already know AC is equal to BD, then you can say their halves will be equal as well. Then ultimately you can take any of these four corresponding to triangles out of 4. You can easily prove their adjacent angles to be equal. Then you can take linear pair and you can easily prove that each angle is 90. So that will be the proof that we are going to do today. So I hope you guys understand this, because I'm going to start with the proof now. So let's see what we have to do with this. So proof. Before that, let's write given as well, so that you guys don't get confused in this. So firstly, let's write given. So what have we been given? We have been given that ABCD is a square, right? We have been given that ABCD is a square. So you can ultimately say AB is equal to BC is equal to CD is equal to DA. That is the main thing, you guys understand this, right? AB is equal to BC is equal to CD is equal to DA, right? This is DA, don't get confused. Also, you guys already know angle A will be equal to angle B, will be equal to angle C, will be equal to angle D each. That is the property of a square. Now required to prove is what? Required to prove is AC is perpendicular to BD and AC bisect BD. That is, these are the two things that we have to prove for this. Let's start with the proof now. So how we are going to do it? We are going to firstly take in triangle ADB and triangle ADB BCA. Alright, so triangle BCA, naming is important, that is why I'm just putting it towards you clearly. ADB BC. So we have taken these two triangles. Now I already know that AD is equal to BC, that is given to me. Angle DAB is equal to angle CBA, that is 90 each. And I already know AB is equal to BA, that is common, right? We have been given these, you already understand this. So these are the three things that we are going to take today. So you guys see side, angle, side, then you can say triangle ADB is congruent to triangle BCA, that is due to side angle side congruency criteria. Now you can do what? You can easily say AC is equal to BD, right? That is CPCT, congruent part of congruent triangle. Now you have just proven that the diagonals are equal. Now we have to do what? We have to prove that their bisected parts are equal to, that means they are bisecting each other. So for that case, let's come to the second part of this one. So I'm going to erase this one. I hope you guys have noted this one down. If you haven't, don't worry. We have the recorded session available on our website and our application. You just have to download that and you can just get yourself registered, and you will be having entire notes there. You will be having recorded sessions there. So don't worry if you haven't taken a proper note of this. We have revision notes as well. You can just download them while getting yourself registered as well. We have practice questions there. So for the second part, for the part where we have to prove that the diagonals are bisecting each other, we have to do what? We have to just go for this. In triangle AOD, that means this one, and triangle BOC, that means this one. Now for this case, what can you say about this? See, I know, firstly, before we get to this, let me just write this. I know ABCD is a square which can be called a parallelogram too. See, square is a type of a parallelogram as well. So I can say AD is parallel to BC and AD is equal to BC, right? That is the case. So if AD is parallel to BC and BD is a transversal, then can I say this angle ADO, or you can say ADB, choice is yours. Let's call this ADB will be equal to angle CBO or CBD, choice is yours. You can name them accordingly. See, ADB, CBD, right? Both will be equal, alternate, interior. Similarly, you can say angle DAC, which is this one, will be equal to angle BCA, which is that one. Again, alternate interior, and you guys already know their BD was transversal. Here you can say AC is transversal, right? So you guys see, if angles are equal and you guys already know AD is equal to BC, then you guys have already proven your part. So we have to do what? Let me just erase this. Since we have to take these two triangles and I know alternate interior pairs are equal, so we can just simply say using angle side angle triangles will be congruent and you have your proof. So in this case I can easily say that let's just prove this one. Yeah, AD is equal to BC, AD is equal to BC, angle ADO equals to angle CBO, angle DAO equals to angle BCO. This is given, this is proven, this is proven obviously. So you guys see angle side angle. Don't get confused here. This is not side angle angle or angle angle side, because we have the common arm which is sharing the both of the sides equal, both of the angles equal to the common arm which is sharing the another equal angles as well. So here we will be using angle side angle, and triangles AOD will be congruent to triangle BOC. That is the main thing to be noted here, and you can ultimately say this: OD is equal to OB, OA is equal to OC. Now this is, let's call this one our first and this one our second, and I already know AC is equal to BD. Then I can say OA is equal to OB is equal to OC is equal to OD, because OA and OC is half of AC, OD and OB both are half of BD. If their wholes are equal, then their parts are equal as well. So that means diagonals are currently bisecting each other. Now we just have one more step left in which we are going to prove that they are bisecting each other at 90 degrees. So for that case, we just have to take two adjacent triangles for this one. Now choice is yours. You can take any two triangles because we have the parts that we are going to use to prove them congruent. So you can take any two pair of adjacent triangles. Choice is yours. But for me, if you ask me, I will be taking these two triangles right here. That means in triangle AOD and triangle COD, we are going to take these two adjacent triangles. I know AD is equal to CD, I know OD is equal to OD, and I know OA is equal to OC. This is given, this is common, and that one is proven, right? So side, 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 triangle AOD is congruent to triangle COD, and you can easily say what? You can easily say, you can easily say both of the triangles are congruent, and you can say angle AOD is equal to angle COD, CPCT, and you can take the linear pair as well. So angle AOD plus angle COD equals to 180 linear pair. Since both of the triangles are same, so you can say twice of angle AOD equals to 180. Angle AOD is 90. If AOD is 90, angle COD is 90. Vertically opposite, COB will be 90. Vertically opposite, AOB will be 90. So diagonals are equal. They are bisecting each other at right angles. So we have just proven that part. I hope you guys have understood this because I have explained it to you very deeply. I hope you guys were able to understand each and every part of this one and you are not having any doubt in this. Now let's see what we have for the next part. Let's see for the next question. So we have this question with us. It is what? It is this one in which we are going to do what? We have this. Show that if the diagonals of a quadrilateral are equal, we have been given that the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. If the diagonals are equal, they are bisecting each other at right angles, we have to show that it is a square. Now whatever we had done in our previous sum, we have to do exactly opposite. Here we are going to approach the question with the bottom up approach. So you guys see, we have been given a quadrilateral and we have to prove that it is a square. So for a moment I will be doing what? I will be assuming this, that this is the case. So let's say ABCD is a quadrilateral in which I know diagonals are equal, AC is equal to BD. That is the main thing to be noted here. We don't know anything else about this one. We have to prove that it is a square. So for this, see, diagonals are equal and bisect each other at 90. So this will be 90, that will be 90. This will be 90, that will be 90 as well. So for this case, we have the simplest approach that will be quite easy to get. See, your first motive here, you should be having that we have to prove that all of the sides are equal. That is the main thing to be done here. Since only in square we have the diagonals. Actually we have in the case of rectangle, but not entirely. In case of square we have this property that diagonals are equal and they bisect each other at 90 degrees. So we have been given half of the portion. We just have to make sure that each of the side is equal. So once we have proven that each of the side is equal, we can say that figure is a square, but that can be a rhombus as well. Don't get confused there. See, that will be the thing. So for that, in order to completely make sure that the given figure is a square, we have to do what? We have to make sure that these two angles, any two pair of adjacent angles or co-interior angles have to be 90. So that will be the main thing. If we have proven that each of the angle is 90 in the given figure and all of the sides are equal, then we can easily say that the figure is a square. So for proving adjacent sides to be equal, we can take these two triangles, right? You guys remember we had approached with that approach also. So you guys see, I know diagonals are equal and bisecting each other. That means if this point is O, I can say AO, sorry, or you can say OA should be equal to OC. This side is common and this angle is 90 and that is 90. Side angle side, triangles are congruent. You can easily say that both of the sides are equal. Then you can move towards these two. You can jump to these two triangles. You already know OB will be equal to OD, OA will be common. You can say AD will be equal to BA. These two are equal. And then you can jump towards these two. Then you can easily say BA is equal to CB. Then these two, you can easily say these two. So you guys see, all of the sides will be equal. Diagonals are equal. They are bisecting each other at 90. So mostly your work is done. But for the last part, you have to do what? You have to take these entire triangles. That means DAB and CBA. You can easily say DA is equal to CB. This side is common. And DB is equal to AC. Diagonals are equal. Then you can easily say CPCT. These two angles are equal. Since these two angles are equal, then you can easily say these two are equal. Then you can prove the other two as well. These two will be equal, and you can take what? You can take the sum, or you can just do what? Take a linear pair here. You can do variety of things with this one. Since opposite sides are equal, you have already proven that. So you can consider that the lines are parallel as well. So you can easily say in the case of parallelogram, sum of adjacent co-interior angles is 180. Then you can easily get the remaining angles to be 90 each. So we can go around with various ways. So that will be the case for this one. Now let's just start with the sum and let's see what we have to do on this. I hope you guys have understood the proof that we are going to attempt today. So for the case of given, we have been given that ABCD is a quadrilateral. ABCD is a quadrilateral in which AC is equal to BD, OA is equal to OB is equal to OC is equal to OD. These are the two things that I have been given. So I will be using only these. Now required to prove is ABCD is a square. So if you guys remember the properties of square, so firstly you have to make sure that AB is equal to BC is equal to CD is equal to DA, and angle A is equal to angle B is equal to angle C is equal to angle D, 90 each. So we have to prove these two things, because if we are going to leave it here, there will be a certain doubt that whether the figure is a square or it is a rhombus. So we are not going to create any doubts in the mind of examiner. So we are going to do what? We are going to do extra just to make sure that our proof is thorough and it is quite speaking loudly to the examiner that I have done it correctly. So let's start with the proof then. Let me just change the ink. So proof. So you guys see, in a previous sum, we had taken the bigger triangle first, then we went towards the smaller ones. Now in this case, we are going to start with the last portion, that means these two smaller, then we are going to jump towards our bigger ones. That will be the case, we are going to do that one. So for this, you're going to do what? Let's start with the proof. So in triangle AOD and triangle COD. So if we do this, we can say, I already know OA is equal to OC. I know OD is equal to DO, that is common, and angle AOD is equal to angle COD, that is 90 each. This is 90 each, this is common, and that one is given. Right? You can say side angle side. Again, don't get confused here. I have written it like this, but there is no such thing as side side angle. Sorry. So if you have any doubt, go back to the video or earlier sessions that are available on our website. You can have that doubt cleared. I have explained accurately why such thing is there, that there is no case of side angle. For that, you just have to get yourself registered, or you can just go through our playlist. You will be getting that video also. So for now, I can see using side angle side, triangle AOD is congruent to triangle COD. Right? They are congruent, so we can easily say AD is equal to CD. Here I want to point out, see, while we have proven the two figures to be congruent, only then we have the ability to prove the remaining portions that haven't been used in the proof to be congruent. Listen carefully. We cannot assume the things that have already been used for the congruency part to prove them congruent to some other thing. That cannot happen. See, I cannot say OD can be equal to AD. That is the main thing to be noted here. Whatever you have used for the proof, you cannot use them again to prove towards something else. You cannot use CPCT for already proven things. CPCT can only be used for those parts which haven't been used in the proof, but they are supposed to be congruent. So AD is supposed to be congruent to CD. Now similarly, if triangle AOD becomes congruent to triangle AOB, then you can easily say AD will be equal to AB. Similarly, if triangle AOB becomes congruent to triangle BOC, so you can easily say AB will be equal to BC. And lastly, since these two end up becoming congruent, if triangle BOC becomes congruent to COD using same methods, you can easily say BC is equal to CD. Then you have this: AD is equal to C, AD is equal to CD, AD is equal to AB, AB is equal to BC, BC is equal to CD. Ultimately, you can say what? You can say this proof is done that AB is equal to BC is equal to CD is equal to DA. We have just proven this one. See, I am leaving it like this, but in exam, I will be wanting you guys to prove these triangles as well, prove them congruent too, in order to get good marks, in order to get a better impression on the examiner. See, if this question is in under 3 marks or 2 marks, then you have to do what? You have to just prove it like this, and you can write similarly and you can do it like that. But if this question is around 4 to 5 marks, then you have to do what? You have to do it fully. You have to take the pair of triangles, you have to write in a proper systematic way, and you have to prove them that this is why we can say the figure is a rhombus or whatever. Now I know since the sides are equal, the first thing I can say now is that the given figure is what? A given figure is a rhombus. So I'm going to erase this since we don't need this one and I need space. Just give me a second. So the first thing I can say now is ABCD is a rhombus. That is the first thing that comes to my mind while I'm looking at this figure. Now for the remaining portion, we have to make sure that the sum of adjacent angles have to be 90, and for that matter, firstly we have to make sure that the lines are parallel. So for that matter, you can do what? You can take these two triangles, you know this is equal to that one, this is equal to that one, these are vertically opposite, then you can easily say this angle can be equal to that one, this angle can be equal to that one. Since pair of vertical alternate interior angles are equal, you can say lines are parallel. AD will be parallel to BC, then this will be the transverse, and ultimately you can also say if the lines are parallel, then their co-interior angles have to be 180. That is the case for once we have proven the angles, base angles to be equal. For that, firstly we have to make sure that the base angles are equal. So for that case, lastly, in triangle ADB and triangle BCA, these two triangles, I know AD is equal to BC, that is proven. I know AC is equal to BD, that is given, and I know AB is equal to BA, that is common. So side, triangles are congruent. Triangle ADB is congruent to triangle BCA, right? These are congruent. Now you can easily say angle DAB will be equal to angle CBA, CPCT. Base angles are equal. Then you can do what? You can simply, if you don't want to go with that method in which you are going to take these two triangles, then you have to take these remaining triangles, that means BCD and CDA. You have to take these two, then you can easily say this angle will be equal to that one. Then ultimately you will be proving each and every angle to be equal, and ultimately you can easily say four angles are equal, sum of the angles is 360, then each angle has to be 90. So there are various ways in which we can jump towards this in order to get the solution, but that will be lengthy. I just want to do it simply. So for one last way, in order to prove that the given, or you can just easily do this one. See, you guys already know I have proven that the given figure was a rhombus, and rhombus is a kind of a parallelogram as well. So I can easily say angle, or you can just let me do it. Since ABCD is a rhombus for now, ABCD is a rhombus, which is a kind of a parallelogram, So I can say AD is parallel to BC, and you can say BD is a transversal, right? If this is the case, if AD is parallel to BC, you can simply say angle DAB plus angle CBA has to be 180, sum of co-interior angles. Then you can say angle DAB will be 90, angle CBA will be 90, and similarly you can prove each and everything. So angle CDA, that will be 90 as well, and angle DCB, that will be 90 as well. So in a figure, if all of the sides are equal, diagonals are equal and bisect each other at 90 degree, and each angle is 90 degree as well of that figure, then that figure is a square. So you can say ABCD is a square. And this is what we had to prove. I hope you don't have any doubt in this. That will be the proof of this question. I hope you have understood this and you don't have any doubt. Now let's move forward and see what do we have for now. So the next question, it is this one. We have been given that ABCD is a rhombus. We have to show that ABCD is a rhombus in which we have to show that AC bisects angle A as well as angle D, and diagonal BD bisects angle B as well as angle D. So for this, let's just prove this one. So for this, firstly, let's draw a rhombus. Let's say ABCD is a rhombus. Okay. Now guys, see, there are various ways in which we can prove this, that the diagonals AC and BD are bisecting the respective angles at the vertices of the origin. That means this half is equal to that half, this half is equal to that one, this half is equal to that half, and ultimately that half is equal to that. So there are various ways in which we can prove this one, but the easiest that comes to my mind if we want to prove this one is, see, you guys know in the case of rhombus, opposite sides, adjacent side, all the four sides are equal for that matter. If we do what? If we just go towards the congruency, then we can say what? I know in rhombus diagonals are perpendicular bisector to one another, so you can say this will be 90. This part will be equal to that one, this part will be equal to that one, and you can easily say if we have taken these two triangles, we can say half of this will be equal to half of that. You can say using simplicity these two are equal as well. Similarly, we can say these two are equal as well, and these two are equal as well. See, what I'm trying to tell you, if we take triangles AOB and triangle AOD, if we have taken these two triangles and I know the given figure is a rhombus, then diagonals have to bisect each other at 90 degrees. That is the main property of rhombus. All the four sides are equal as well. And here you can use your RHS also. See, these two sides are equal, this side is common, these two angles are 90. You can easily prove that using RHS. Even diagonals are bisected to one another as well. But here we have to prove that diagonals are just bisecting angle A and angle C, that being the diagonal AC, and angle B and angle D, that being the diagonal BD. So for this, we have to prove that these two will be equal, these two will be equal. Similarly, these two will be equal and these two will be equal. We have to actually prove that they are equal to themselves. Now for this, if I just erase this one more time and draw it neatly to tell you the proof of this. So you guys see, if I consider these two triangles for a moment, let's say ABC, D, these are the two triangles, and you guys see this side is equal to that one, that side is equal to that one. Obviously they are equal to one another as well. Then you can say this side is common. Easily you can say this complete is equal to that one, this half is equal to this, and this half is equal to that. That is the main thing. Then we can do what? We can just get rid of this diagonal, then join BD. I already know these two angles are equal fully, but we have to do what? We have to prove their halves are equal. We can similarly prove their halves equal as well. That will be the main thing. There are various ways, but the simplest method I can think of here is that, since if we look at this triangle, let's not erase this one. If we take at this complete triangle ABD, let's get rid of this one. If we take these two triangles ABD, I know this part will be equal to that one. Since angles opposite to equal sides are equal, and I know AB is equal to AD. So this angle 1, let's name this one angle 1, angle 2, angle 3, and angle 4. So angle 1 is equal to angle 2. Similarly, if I go down, I can see angle 2 is equal to angle 4, right? They are equal. Similarly, if I join these two, and let's name this one 5, 6, 7, and 8. If I consider these two triangles, if I consider this entire triangle ABC, I know 5 will be equal to 7 and 6 will be equal to 8. But here, listen to me very carefully. You guys already know rhombus is a kind of a parallelogram as well. If rhombus is a kind of a parallelogram, then if I just consider this one, if I just for once get rid of this, Bear with me, don't get confused. I am just explaining it very effectively to you. You don't have to go towards your congruency. The method is correct. It is actually correct. Now you guys see, if you look at this one, if you look at this side BC and AD, since it is a kind of a parallelogram, then BC and AD can be parallel too. If BC and AD are parallel and BD is acting as a transversal, then you guys can do what? You guys can say angle 2 will be equal to angle 3, angle 1 will be equal to angle 4. Alternate interior angles. And you guys already know angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Since they are equal in cross as well, they are equal directly. You can easily say angle 1 is equal to angle 2, angle 3 is equal to angle 4. That is the basic approach to this question. See, I will be using this one. I will be explaining the method of congruency to you later on. You can use that one on your own. So for last case, let me just draw a triangle now. Sorry, a rhombus now. So for this is the last time we are going to draw a rhombus. So this is the case. These are the diagonals. I hope you guys get this. So A, B, C, and D. Since I know ABCD is a rhombus, and in rhombus AB is equal to BC is equal to CD is equal to D, right? That is the main thing. So if I take triangle, in triangle ABC, I can see AB is equal to BC, AB is equal to BC, then can I say angle BAC will be equal to angle BCA, right? Angles opposite to equal sides are equal. See, usually what happens here is some of the teachers will be telling you to just do the way of congruency, use congruency and prove that one. We don't have to go towards congruency since we have learnt these things, these theorems in chapter 7. I had told you while we were doing these, I have specifically told you that you guys will be needing this one in your coming chapter as well. So we don't have to go towards the congruency since we have the proof already with us. So the angles will be equal because angle opposite to equal sides are equal. Similarly, in triangle DCA, sorry, DBO, you can take that one. Let's take DCA for first. In triangle DCA, I can say angle DAC equals to angle DCA because AD is equal to CD. So angle opposite to equal sides are equal as well. So for this, for your reference, I will be calling this one. Let's name them so that you don't guys get confused. So let's call this one 1, 2, 3, 4, 5, 6. This one 7 and that one 8. So guys, see, according to this, I know BSC is angle 8, which is equal to angle 3, and angle 7 is equal to angle 4. These are the things that we have to keep in mind. Also, we know rhombus is a parallelogram as well. If that is the case, if I can say AD is parallel to BC because opposite sides of parallelogram are parallel. So if that is the case, and AC is the transversal. So if AC is the transversal, I can easily say angle 7 will be equal to angle 3 and angle 8 will be equal to angle 4. Why? Alternate interior angles. So you guys see angle 8 is equal to angle 3. Now angle 8 is equal to angle 4 and angle 7 is equal to angle 3. Angle 7 is equal to angle 4. So from this, let's name this one first, second, third and fourth. So from 1, 2 and 3 and 4, let me just erase the top portion since we don't need this one. Let me just erase this. You guys will be understanding this in a bit. I hope you are getting this question and you are finding this one very interesting. So from 1, 2, 3 and 4, I can say angle 8 is equal to angle 7 and angle 3 is equal to angle 4. We can easily say this one. For the case of 7, I can write 3. For the case of 3, I can write 7. Ultimately, we have just proven that one. So we can say AC bisects angle A and angle C. Understood? Now similarly, you can do what? Similarly, if you take these two triangles ABD and CBD, you can easily prove that angle 1 is equal to angle 6 and angle 5 is equal to angle 2. Since they will be parallel as well, you can easily say angle 2 is equal to angle 6 angle 1 is equal to angle 5. So similarly, in triangle ABD and triangle CBD, I can say angle 1 is equal to angle 6, angle 2 is equal to angle 5. Also, AB is parallel to CD and BD is transversal. So I can say angle 1 will be equal to angle 5, angle 2 will be equal to angle 6. So ultimately you can say angle 1 equal to angle 2, angle 5 equal to angle 6. Therefore, BD bisects angle A and angle C. Sorry, angle B and angle D. Pardon me, it has angle B and angle D. So I hope you guys have understood this and you don't have any doubt on this, because that will be the point right here. So this was an effective way to prove them, but you can obviously take the help of the congruency. So for that, I'm going to explain that method, and that can be your homework for today. So you guys see, if I had drawn the rhombus and we had gone towards the congruency. So in order to prove that the diagonals, the angles are being bisected, firstly we have to make sure that the angles were equal themselves. So for that case, we had to do what? Firstly, we had to make sure that the angles were equal. So guys, see, this side is equal to that one, this side is equal to that one. This side is common, I can easily say this is equal to that. Base angles are equal. Similarly, we could have erased that. Let me erase that. And if we had joined this one, this side was equal to this side was equal to that, this side was common, these angles were equal as well. So guys, see, opposite angles were equal in rhombus. Then the work started. Now you had to do what? You had to take the diagonals, that means they were bisecting each other. So you have to take the little triangles as well. If I had drawn the diagonals now, A, B, C and D. So guys, see, you have to take two triangles at a given time. Then you have to make sure that if you have taken these two, then using CPCT you will be proving these two angles equal. Then you will be taking these two, then using CPCT you will be proving these two equal. Then these two, using CPCT you will be proving these two equal. Finally these two proving CPCT equal. How? This part is equal to that one, this side is common, both are 90. You can easily prove these two. Similarly, this 90, this 90, this side is equal to that one, this is common, equal. 90, 90, common, equal. So you get an idea how you're going to use congruency in order to prove this one. If you want to use congruency, you're most welcome to do that, but try to be different rather than going in a herd. So that will be the main thing to learn here. Understand, you have to attempt each and every question. Logically you have to be different. Don't just go as flock of sheep. That will be creating a doubt in the mind of a teacher that you are copying. You don't have to copy that, you can use that method as well. So let's see what do we have for the last question. This will be the last question for today, because the session is almost getting about 50 minutes. I don't want to bore you guys. We can always shift towards the next session. So you guys see, ABCD is a rectangle. Listen carefully. ABCD is a rectangle in which you have been given what? You have been given that AC bisects angle A and angle C. Show that ABCD is a square, and diagonal BD bisects angle B and angle D as well. Now you guys see, this is an important question in which you have been given what? Let's start with this. We have been given a rectangle. Let's just do it like this. So we have been given ABCD is a rectangle in which diagonal AC, if I join diagonal AC, it bisects angle A as well as angle C. So we have to show that it is a square. It is quite easy to prove. See, this angle equal to that one, this angle equal to that one, this side common, CPCT, AD is equal to AB. Since it is a rectangle, opposite sides have to be equal. So you can say if AD is equal to AB, then AD is equal to CD, AD is equal to BC obviously. So you guys see, all four sides are equal. This will be what? Since in rectangle each angle is 90, you can easily say this can be a square, because see, the case is diagonal as well. If you want to go one step further, then you have to take another diagonal, then you have to prove that diagonals bisecting each other. But in our case, we have to just prove that diagonal BD is bisecting B and angle D as well. So for that case, let us join BD. And I know here we can use the proof that we have taken earlier also. So you guys see, here we can go with one more method that I will be using today. But for now, we can do what? In this case, the same method here, we can do what? This side is equal to that one, this side is equal to that one, this side is common. You can easily say this angle will be equal to that one, this angle will be equal to that one. Proof. So BD bisects angle B and D as well, using the case of congruency. But you can do it with one more method here. See, if I erase this one, so you guys see, if ABCD is a rectangle and AC is bisecting angle A as well as angle C. Now, in your mind, you guys know rectangle is also a kind of a parallelogram. So if that is the case, then in parallelogram you specifically had learnt that opposite sides are parallel and equal. Now in our case, opposite sides are equal, indeed equal. AD is equal to BC, AD is parallel to BC as well. So you guys see, pair of alternate interior angles have to be equal. So this will be equal to that one, and this will be equal to that, right? And you guys see, if that is the case, and I know this part is equal to this and this part is equal to this, ultimately these two angles will be equal. See, 1, 2, 3, 4. Since AD is parallel to BC, angle 1 has to be equal to angle 4 and angle 2 has to be equal to angle 3, right? That is the main thing. But I know angle 1 is equal to angle 2 and angle 3 is equal to angle 4, right? That is the thing here. So can I write in place of angle 4 angle 3? So angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Obviously I can. So you guys see, if base angles are equal, then sides opposite to equal angles are equal. If this is the case, then sides opposite to equal angles are equal, right? So you can say AD is equal to CD, and similarly you can say AB is equal to BC. But you guys know ABCD is a rectangle, or you can say it is a parallelogram as well. If it is a rectangle, you guys know AD has to be equal to BC, but AD is equal to BC and AB is equal to CD. And you guys see, AD is equal to CD, AB is equal to BC. So ultimately you can do what? You can simply say AB is equal to BC is equal to CD is equal to D. All four sides are equal. In a rectangle, each angle is 90. Angle A is equal to angle B is equal to angle C is equal to angle D. That is 90. So a figure in which each angle is 90, all the four sides are equal, you can say that will be a square. So first part is done. Now you have to prove that it is bisecting angle B and D as well. So the proof is quite easy. Since you already know this is equal to that one, this is equal to that one. So if I name the remaining angles, 5, 6, 7, 8. So you guys see, since that is the case, you can easily say that angle 5 will be equal to angle 7, considering AB will be parallel to CD, because it is what? The square is also kind of a parallelogram. So 5 is equal to 7. And you can do what? You can say angle 8 is equal to angle 6, alternate interior. But you guys already know AD is equal to AB. So you can say angle 5 is equal to angle 8 and angle 6 is equal to angle 7. That is the main thing. Since this is the case, you can say angle 5 is equal to angle 6 from this, and angle 7 is equal to angle 8. This. So ultimately, using just the theorem from your chapter 7, you have proven the entire sum. Keep in mind, if you have used this method, this is not wrong, this is totally correct. You can use the case of congruency as well, then you can prove this one. You will be finding that once you have taken the step towards congruency, your sum is quite lengthy. While this is not lengthy, see, it was quite simpler. You have to use it effectively and simply so that your calculation or your proof does not get a bit lengthier. It is effective and easy to understand. It is easy to be understood, so you can easily do this one. I'm gonna wrap the video right here. This will be the final sum for today because we have almost 10 minutes left and I don't want to bore you with those 10 minutes as well. You just have to relax. So remember, we have done around 3 sums today. Yeah, we have done 3 sums. So practice these first 6 sums for now. You have to practice first 6 sums from exercise 8.1. Then we will be pushing towards our remaining sums tomorrow. And hopefully we will be trying to complete our exercise 8.1. See, the sums are quite lengthy. And I have to explain each and everything because we are doing it for the first time. You guys are doing it for the first time. There is no point of me for just going it like this. This is like this and this is like that. Just for the sake of completing the exercise, I want you guys to understand it deeply and completely so that if they have molded questions some way, you guys will be understanding how to attempt that one. So this is the main motive. With that being said, you have to practice for 6 questions, and in order to practice furthermore, or in order to get some recorded classes as well, there are 2 ways. First one is shuffling towards our video from our playlist on YouTube. The simplest way is get to our website. Along with the recorded sessions, you will be getting a lot of new things there. You will be getting revision notes, you will be getting question banks, test series. A lot of things is there. You can interact with me, you can have your doubt sessions with me. So that is, I think, a brilliant deal for you guys. So get yourselves registered, download our application. I'll be seeing you on our app as well. So bye for now. Practice as much as you can. Remember, you have to practice each and every sum on your own. If you're having any doubt, you can post to our website. I will be happy to clear your doubts. So that being said, I'll see you tomorrow. Bye for now.